seems not.
So good morning, everybody. Thank you. Well, first, I would like to thank the organizers of this conference on the history of geology. Claudine Cohen, Françoise Dreyer, Gaston Godard, et Pascal Richet. Well, you may read the title of this talk. Well, I would like to stress first that my knowledge in the history of geology is limited when compared to yours. I'm both a geologist and a physicist, interested in the philosophy of science. I am particularly interested in the so-called relational or relation-based thinking. It has been discussed by many philosophers. It is also called a complex reason by French philosopher Edgar Morin. So I propose an epistemological look at the history of geology. But actually, the fertilization went both ways, from epistemology to geology, and from geology to epistemology and physics. And I will try to show you here how geology and its deep time inspired my reflection on the fundamental concepts of space and time in physics. And well, this led me to some surprising conclusions. So here are the main parts of my talk. First, I will make some reminders about deep time in geology. In the second part, I will make a stop about space. Paradoxically, space was not discussed as such by geologists, in my understanding. I will then present my founding thought experiment that was inspired by geology. And we will end by some consequences of my vision of space and time, both from a general standpoint and in geology. I will make an allusion to prehistory. This is the main topic of our conference. So let us start by our first part. Here you may read a list of books and works in a chronological order that I have consulted to prepare this talk. Of course, there are many other books and works I do not know or that I did not use. I have also outlined their main contribution to my reflection. For instance, I was interested by what Stephen Jay Gould told about Houghton. As you may see, some of these authors are members of the organizing committee of the present conference. For instance, Pascal Richet tells us that the dialogue between geologists and physicists is not always fraternal. I was also interested about what Claudine Cohen tells us about imagination and science. I think it is an important issue when we discuss relational rationality. So here are some lessons among so many others learned from the history of geology. I found many quotes from Houghton in the books of François-Hélène Berger. Houghton is known for his contribution to highlighting the continuous changes of the Earth's surface. He speaks of the interchanging of sea and land, tells us about the vicissitude of sea and land more than once. And Charles Lyell stresses that the slow and continuous action of the present causes produces the whole of the geological events. Well, of course, all is well known, and I am not original, and you know it better than I do. But from my epistemological perspective, I would stress that in the mentioned works, the existence of time is not questioned, and time is not defined either. During centuries, when the works by Newton were known, especially in England by Hutton and Lyell. For his part, Newton defines an abstract time, I would say a substantial time, detached from the phenomena. But on the contrary, deep time, geological deep time, is not substantial, not abstracted. It is relational, as based on the phenomena. Well, let us go to make a stop now about space. In the previous lines, scholars did not find any problem with space, although deep time is understood through the changes of concrete space. The immensity of time is seen through the slow alteration of the tangible space. So maybe we could say that whereas deep time is relational, space in geology rather looks as absolute, still in the sense of Newton. Newton has detached everything, as much time as space, from the objects. And I put some quotes from Newton.
Sorry,
about space.
Sorry, just a moment. There is someone that have an internet connection opened near here in the room.
It's somewhere listening on from the internet outside. Please mute yourself. Your mic is open.
The microphone open.
Well, about what I'm still speaking of space, and while geologists were thinking about the changes of space, geographers, physicists were preparing maps, wondering about the shape of the Earth. And also in mineralogy and geology, the first maps were offered. So could we say that geologists identified changes of a concrete space inside an abstract space? This duality of meanings for these two spaces is important to me, as I developed it in some separate works. In brief, deep time refers to material space. And for me, we must still clarify the link and articulation between this tangible space and concrete time as offered by geology. Geology offers both a tangible space and a concrete time, at variance with what Newton hopes and tells us. And I even think that geology helps us to think about a strong fundamental link between space and time. And this is what I will explain with the announced thought experiment. But before we go to our thought experiment, it is useful to make a stop about relational thinking. Because as you guessed from the previous slides, the matter is to define the functioning of a relational rationality and apply it to our subject. We speak of relational rationality when we cannot go outside the world. We can only compare the objects to the others. We are then led to adopt arbitrary, it means open to free will, conventions to stop endless regressions. In this understanding, movement has the primary role, as we will develop. Movement before, I would say, in a sense, before space and time. relational rationality is opposed to substantial rationality. This is the case when we believe that we can contemplate the world from the outside. So it is time that I present my founding thought experiment that was inspired by geology and show you how geology took me so far away. So let me present my vision of time. Well, in my understanding, time does not exist. Well, it does not exist alone as an independent substance of the world. It is abstracted from the world, from which it cannot ultimately be separated. And specifically for me, time is abstracted from the movements in space of the material entities in the large. However, when we abstract time, we construct an object which has pragmatic effects that can be studied and discussed independently. So for me, the understanding of time is the understanding of the abstraction of time. To tell it short, time and space is the same. To avoid too many words, I make use now of what French philosopher Bergson called the philosophical intuition. I call it the comprehensive relation-based thinking, often made of images that comes in composition, not in opposition with the discursive, disjunctive, substance-based thinking, mostly made of words. And for issues that concern us, we especially need both. So let us have, as Bergson also commented in this context, an artistic approach in a way, trying to grasp at once as a whole the objects of thought. So how to speak of space and time? Well, let us start by repeating that neither space nor time exist by themselves. They are based on the phenomena of the world. And let us look at this landscape as other people have done before us. Well, to define space, you use some benchmarks borne by the mountains as geographical markers that are planted there as a set of points connected by the GPS network. And on each side, time is defined by the sun going across the sky. Well, you don't see the sun here, or as the clouds, or as this cart, you see maybe this cart on the painting. Their movement allows us to classify, to sequence the events. When the cart was here, I did this. When it was there, I did that. Well, this is another landscape, another vision of time and space. You may see a mountain that allows us to build space, and ocean waves allow to build time. Their progress may serve us as a clock. So in what we have done, we feel that we can look at space with no need to look at time. Well, but this is not the case, and this is the heart of my discourse. Time and space are not only related to the world, but they are also relative to or in relationship with each other. And well, for a proof, a change of scale is necessary. And with geologists, let us think through tens, hundreds of millions of years. And so then the stone wave is then strictly identical to the ocean wave that we just saw a short time ago. It moves like it and can serve us to measure time. And so which served to define space now serves us to define time. Well, you can think of other stone waves. This is the Sainte-Victoire, near to Cézanne, in the south of France. But conversely, if we live at the scale of nanoseconds, the sand in the hourglass does not move for the duration of our entire life. The ratio of the nanosecond to the second is the same as that of the second to the century. The grains of sand may serve us as a distance gauge, and what was used to set time is now used to set space. And of a short time scales, the relief of the river water and its swirls is similar to the landscape we contemplated a while ago. We can pinpoint its irregularities to locate us. So you will say this is a beautiful allegory, but at some point we will be able to stop and say, well, here is space and here is time. Well, I say no. In this infinite transhumance that in a way transforms time into space and space into time, we cannot stop because we are inside the world, and we cannot bring rulers and clocks from outside the world to measure it. We can only compare the phenomena to the other phenomena, and from this comparison, build space and time. So if we stop, it is not that we would have found a pure time, a pure space with words defined in advance as waiting to be used. But this is because we are tired. We stop at a scale relevant to the phenomena that we want or that we can study, and make a provisional sharing between what does not move too much, we build space on it, and what is defined by comparison and that moves more, and we call it time. But we are not sure of the ultimate meaning of the very words that we use to talk about them. Well, of course, this would need longer developments, and here are just some first general consequences. Time and space are of the same nature. They are separated thanks to the multiplicity of relationships and the sharing of them into classes defined in opposition to each other. So we use a relation-based thinking that needs to be stabilized by a decision left to the free will, that of a judgment by which we choose within the same thought a declared constant immobility, the spatial frame, in composition with a declared also constant mobility, the standard movement that to define time, whether human or offered by the physical world on which our knowledge builds and loops. The postulates of relativity theory are there. There are hidden conceptual loops in this process. In a way, we need movement to define movement. A speed is defined by comparing two movements, one of which is selected as a standard. They are no longer rulers nor clocks, but only a standard movement. So we do not talk about the speed of light because it is what defines both the standards of space and time. Or we can say that this speed is unity, or merely say that the light is the standard of movement. Initially, times are plural, as are spaces, supported by the multiplicity of local movements. All is not solved, of course, but the mystery of time is moved. But we have new keys to reread many issues, from humanities and social sciences to physics. Well, of course, you will be interested that we make some reference to the consequences in geology. Of course, this would also need longer developments, but I would like to stress that the different concepts that we find in the history of geology, such as cyclic versus sagittal time or uniformitarism versus catastrophes, etc., must not be studied separately. One should not try to argue how to choose one over the other. All these concepts are defined in opposition relation to each other, and the boundary between them is a matter of convention. We cannot do it any other way, and it is interesting to put the finger on the point where we have made the convention. On another standpoint, we may stress that the increasing part in the vocabulary of geology, the increasing part on processes. This is found in all the fields of geology, and well, examples are given here in the fields of metamorphism, metasomatism, magmatism, and tectonics. And here are some examples in sedimentology. The names of rocks such as limestone, sandstone, claystone, and so on now come together with names of processes. More generally, a rock name is substantial, but a cut has been made between space and time on our human scale. On longer scales, a piece of granite, for instance, is transient between the solidification of a magma and the weathering at the surface of the Earth. This joins with the considerations, for instance, of French writer Roger Caillois and others on the use of geological symbols in philosophy or in poetry. And in prehistory, some authors now discuss the spatial dynamics of territories, the progression of archaeological finds in space and time. Maybe the input of our studies may bring some epistemological and lexical enlightenment, and to discuss the place where some conventions are made. These conventions sustain our choices to describe the history of ancient men. Well, yesterday, Claudine Cohen told us about the limits of geology as a method to help the archaeological work. She tells us that geology, there is a limit because the vertical succession of strata seems to forget the question of processes and diffusion of cultural diversification. I would say that I agree with her, and as an answer, I would stress that geological superposition principle must never be separated from a principle that we could phrase as a horizontal mobility principle applying to contiguous rock types. Well, it is similar to modern so-called sequence stratigraphy, sequential. And in his work, Gaston Godard also discusses the superposition principle and the mobility of seas. Well, we just end with some quotes by a French geologist who was also paleontologist and prehistorian. And with him, we can speak of waves for geology, as well as for living and human groups. And natural and human waves may compete or work together. Well, I thank you for your attention.
So thank you, Bernard. We are full in time. We have time for some question if you have about this intervention on philosophy of science. Please. And sorry for the noise during during your intervention, but I think it's something outside. But in any case, yes, okay. Yes, if someone have a connection of internet open, please shut the microphone because it's directly on the room. Okay, questions?
Maybe just a quick comment. You might be interested to know that Hans Cloos, a German geologist, liked geology to the music of the earth. So he really envisioned an image of mountains and their waves, like music, like sound waves.
Oh, thank you, thank you. You will tell me the name and I will write it. Thank you.
Yeah, now that's interesting and stimulating. But could you give a concrete example of the kind of inference you can draw from this reasoning on geology?
Yes. Well, I have given some my way of understanding maybe the link between processes and names of rocks and so on in geology. But as I told you at the beginning, I am also a physicist. And actually, geology helped me to understand the concepts in physics. And it is on the side of physics that I have many examples to tell you. Well, I may tell you now some examples, but maybe it will not interest all the audience because this audience is interested in geology. But in physics, for instance, I bring new insights to some problems. The twins paradox, for instance, I have also, well, in thermodynamics, I give a better understanding of the second law, and it has been published in review papers. The second law is better understood when you connect better the spatial derivative, the spatial gradients, and the temporal derivatives. You cannot disconnect temporal derivative, the change in time, with change in space. And this is just a few examples. I will give you further examples in physics.
Thank you so much.
I also discussed the so-called Lorentz transformation. It has been published in Société Française de Physique. So the Lorentz transformation, maybe some of you know, it's the basis of relativity theory.
So thank you so much. Your talk really inspired me to think some bit different of the world around us. One question which came up in my mind is that we have in geology a very strong concept of provenance. Yeah, and it's not only about space, it's also time, sediments. It's a very complex concept, and it's also they have the same concept also in history. So provenance plays, just think on archives, plays a big role. So, and I wanted to ask you if how this concept of provenance plays a role in your thinking. How is it related?
You mentioned it is a providence. You said.
Provenance. Sorry, provenance.
Oh, could you repeat, please?
Provenance.
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 Provenance. Well, I'm not sure I use this. Maybe I do not understand how you feel with provenance. What is the role of provenance for you?
When you for example extract or look in some sediments, you pick out some specimens, you bring in the museum, and then you relate these specimens to the place in the field. So it's a very powerful thinking.
Yeah. Yes, maybe I agree with this. Is what I was just telling at the end of the talk, because when you have the superposition and strata and so on, you must connect it always to another place. You relate to another place with the movement. Yes, we can discuss further, but I think it is important. I gave it a more fundamental role to this provenance issue, maybe.
Thank you.